coming to you from the University of Alberta Observatory in Edmonton, Alberta, Canada. Today is Monday, November 8th, 2021, and right now is 7:45 in the evening. It is -1 degree Celsius in Edmonton, and we have a clear sky. And tonight I would like to talk to you about supernova Remnant. We are going to focus on the Veil Nebula. This is a live view of the sky right now over Edmonton. It's a very small section of the sky recorded by our telescope. What you are seeing is a beautiful landscape of stars with a wispy cloud extending from the bottom left of the image to more or less the middle right. You see a kind of a red nebulosity going across the image that is very faint to see. I'm going to explain in a minute what this is, but first I would like to explain what telescope we are using right now because it's important to understand the image. As I say, what you saw is a live image right now captured by our telescope. It's a Newtonian telescope, but instead it has a mirror at the back of the telescope, and instead of having a mirror at the front, like common Newtonians do, it has a sensor, a CMOS sensor. So it has a camera integrated inside the telescope. And that camera allows us to take long exposures, very long exposure images of the night sky. This way, we can accumulate light for a long time, and therefore, we can see very faint objects in the sky. If you look at the bottom of the image that I just showed you, it says enhanced vision on the Eastern Veil Nebula, and it says 40 minutes between brackets. That means that we've been collecting non-stop, accumulating light for 40 minutes, and still the image that you see is actually really faint of this nebulosity. So you can see that this is a very faint object in the sky. With a normal telescope, you can see it from a dark sky, that is a sky that is free from light pollution, or as free as you can. Um, and normally you need a special filter that you can put in front of your eyepiece, and then you can see this nebula by eye with a normal telescope. Here in Edmonton, we have a very light polluted sky, so we need a telescope that is able to accumulate light in order to be able to see it. Okay, so what is a supernova remnant? We are going to focus on the right side of this diagram, and that shows the life cycle of a star. Now we are thinking about massive stars, stars that are 7 times the size of our sun or bigger, because only the stars that massive end up being supernovas. So the stars, while they live, they are in what we call hydrostatic equilibrium. The force of gravity is trying to collapse the star into itself, but the nuclear fusion that is happening inside is trying to pull it apart. And these two forces are in equilibrium, and the star can live for a long time like that. Nuclear fusion happens when we have hydrogen inside the star, but at some point, the star runs out of fuel, it runs out of hydrogen, and then it moves into what we call the red giant state, where the core collapses and the outer layers of the star grow in size, and it starts fusing heavier elements. But eventually it runs out of that fuel too, and then very massive stars go into an explosion called a supernova, where the core collapses so quickly that it creates an enormous shock wave that causes the outer part of the star to explode, thus releasing about 75% of the mass of the star in a cloud of gas around it, and leaving a neutron star or a black hole in the center. All right, so that's what we are seeing now. This is a very small section of the whole gas cloud that was expelled when one of these kind of very massive stars exploded. Now, I'm going to give you some facts about the Veil Nebula. Um, this nebula is located in the Cygnus constellation, which right now is over the southwestern sky in Edmonton. Cygnus is a mythical figure of the swan. You can see it in the image on the right. And the nebula is located at the bottom tip of the bottom left wing of the swan. There is a square labeled 6960, and that's where the nebula is located. That nebula is 2,400 light years away from us, which is to say that the light that our telescope is collecting right now has been traveling through space for 2,400 years to reach to us. The supernova star that caused this explosion is estimated to be between 12 and 15 times the size of our sun, more massive than our sun, and is estimated to have exploded between 10,000 and 20,000 years ago. The expected Remnant star is possibly a neutron star, but it hasn't been seen yet. And so I just would like to show you an image of the whole Veil Nebula, the whole Cygnus loop, what is left in this supernova remnant. This is a picture taken by a amateur astronomer. The section of this image that we are seeing right now is the section shown in the top right area of the image when you see this kind of two arches joined together, topped by a beautiful bright yellow star. That is the Eastern Veil Nebula, and that's the area that our telescope is looking right now. That's what we can see over Edmonton. But as you can see, the whole cloud of gas occupies a much bigger area in the sky on the constellation Cygnus, but it's, as I say, very faint to be seen. And you need a very dark sky and a big telescope, or you need to be able to integrate light for a long time to see it. Right now, this is the image after 45 minutes of integration, and you can see this beautiful red wispy area in the sky, and that's the leftover gas from a supernova explosion that can be seen over Edmonton. And with that, I'm going to tell you good night, and until next time, goodbye.